Welcome to part 3 of SGI's Mesic conservation videos. I'm Jeremy Maestas with the NRCS, and I'll be introducing our next presenter here. Brady Allred is an assistant professor of rangeland ecology at the University of Montana, based in Missoula, Montana. And he's going to be sharing with us SGI's interactive web app and the brand new Mesic resources layer. Brady, I'll go ahead and turn it over to you.
Thank you, Jeremy. And so as Jeremy said, I'm going to talk about the work that SGI has been doing on the web, and in particular, our interactive web application that we've developed. And I'm also going to introduce the new Mesic resources layer. And so as Patrick alluded to earlier, SGI is working on a lot of data products. And we do a lot of work with satellite imagery. And the Mesic resources layer that he described and that he produced, it turns out with all this work we're doing with satellite imagery that there's not a computer big enough in the world to handle all the work we're doing. And so what we ended up doing is that we partnered with Google. We are using some of Google's servers and resources, some of their processing platforms, to do SGI science. And these are the same servers that power the everyday Google products that you use: YouTube, Gmail, Google Photos, Google Drive, so on and so forth. But what Google has done and how it benefits SGI science as well as conservation in general is Google created a platform called Google Earth Engine. And what it is, it's a cloud, a processing platform in the cloud for planetary scale analysis, particularly specializing in Earth science data and remotely sensed data, essentially satellite imagery. And SGI Science and NRCS have been using this to particularly to do these analyses that Patrick has talked about, so we can put better conservation on the ground. Also, so we can monitor our conservation outcomes in the future. The nice thing about this is not only can we use it to do all our science research projects and to look at the results, is because it was built by Google, it was particularly built for the web. So we can use it for all our big scale analyses, but we can harness this computational power and put it on the web and use it for interactive web applications. And so that's what I'm going to demonstrate to you now. So you may know that SGI has a interactive web application. The best way to get to it is to go to the SGI website. So if you go to the SGI website at sagegraphinitiative.com, you'll land on the landing page like this. And then up at the top, there's a link that says Map. If you click on that link, it will take you to the SGI interactive web application. The URL for this application is map.sagegraphinitiative.com. And what you have in front of you is basically a Google Maps interface. Now, the purpose this web application has 3 objectives. It turns out we were developing all these geospatial products to help target conservation and to monitor conservation outcomes, and we needed a better way to display them, a better way for people to get access to them. So the 3 objectives of this application are: 1, to first easily visualize the data and the conservation products that we produce. We wanted something that was simple, that was on the web, that people could go to quickly and easily and just get a quick visual of what are these projects or products. How can they help them? What do they look like? What do they look like in my particular area that I'm working in? The second objective was to distribute data to our partners, to our end users, to the people who are on the ground doing the day-to-day conservation work. They needed a mechanism where they can take this data, put it on their own computer, load it into their own planning programs and software, and use it in their own projects. We needed a way to provide that data very quickly and very easily. And so the web application was also created for that purpose. And the third objective of the web application is the one that excites me the most. It is we wanted the ability for users to have custom-driven analyses or interactive analyses, where a user can go to the web application, put in some data, put in some information, That information is sent to our servers in the cloud and processed, and then the results are spit back on the screen in the web application for that user. And it will help the user to make very specific decisions for the projects and plans that they're working on. So what I'm going to do is walk you through the application, show you how it works, what are the different elements, what you can do, what you can't do, and then I'm going to highlight in particular the new Mesic resources layer that we just made available. So if you go to the web application, map.sagegrassinitiative.com, as I said, this is the first thing you'll see. It's a standard Google Maps interface, something that we're all very familiar with. That's the background layer here. Over here on the right-hand side, we have our different layers that are available, and they're categorized in two separate categories. The first one is ecosystem, and these are ecosystem-focused layers. Right now, we're looking at the new Mesic resources layer. Other layers that we have there are cultivation risk. If you click on it, it will open up and switch to that layer. We also have our ecosystem resilience and resistance layer, as well as our tree canopy cover layer. If you go over to the wildlife category, it'll switch over and show our current wildlife layers. We currently have the fence collision risk layer, as well as some reference layers that will show general sage-grouse information, the current range, the management zones, the packs, so on and so forth. One thing that you can do is you can turn these panels on the right-hand side on and off, so you can have a clear picture of the map without any information blocking your view. I'm going to turn the ecosystem panel back on, and I'm going to go to the Mesic resources layer, because that's what we're going to talk about here shortly. Over here on the left-hand side, we have the map controls. As I said, this is a Google Maps interface. You can go to Map. Right now it has the terrain shown. You can click that off, and you will just have the standard Google Maps interface with the roads, the rivers, the lakes, so on and so forth. You can change that to satellite, so you can get the satellite view. And as you can see here, you can turn the labels on and off. So those can help you navigate to your specific area and where you want to go. I'm going to go back to the map view here and turn the terrain back on. These buttons here will zoom in as well as zoom out, standard map interface buttons and control. You can also just use your mouse wheel or your mouse to zoom in and out. This new button is something we've added here. This is the geolocation button. If you're using a phone or a tablet and you're out in the field and you want to automatically zoom to where you're standing, you can hit this button and it will do that. If I hit this button while I'm sitting here at my computer, it will get the geolocation of where I'm at. I'm sitting here in Missoula, Montana, and it will automatically zoom to that area. So this allows you a quick and easy way to get to the area that perhaps you're standing out in the field. Okay, I'm going to zoom out here, kind of zoom back out to the broader western United States. And what I'm going to do now is highlight our new Mesic resources area, layer. And while I'm doing this, I'm also going to highlight some of the functionality that pertains to all the layers that we have available. So over here on the right-hand side in this panel, the Mesic resources layer is toggle on. You can toggle layers on and off simply by toggling the switch. It's on, off, and back on again. Down here, we have a short description of this Mesic resources layer. And what we're looking at right now is the persistence of these Mesic resources from 1984 to 2016. As Patrick explained earlier, he used satellite imagery to quantify these Mesic resources for every year during this 32-year time period. Persistence was, these Mesic resources were labeled productive if they were over an NDVI threshold of 0.3. I'm sorry, an NDVI threshold of 0.3. What the layer we're looking at right now shows the percentage of years that one of those polygons were productive over that 32-year time period. So what I'm going to do is zoom into the same layer that the same area that Patrick showed you earlier. He was in southwestern Idaho. Let's see if I can find it right here. He was right over here in this little crook right here. This is the same area that he highlighted earlier and talked about this new layer. And so what we can see are the dark green polygons represent Mesic resources that were productive most of the time during that 32-year time period. The yellow or orange polygons are areas that were productive about half the time during that time period, whereas the red or darker colors are the latter end of that spectrum. They may be productive 1 or 2 or 5 years during that time period. If you go over and if you click on one of these polygons, I'll click on this green polygon right here, what will happen is a chart will show up in our panel off to the right. And what this chart shows is it actually gives you the time series information for that particular polygon. So this polygon was green, and meaning it was productive most of the years over that time period. But here we can particularly see that those productivity values. In 1984, it had a value of 0.6 in DVI. So we go over here to 1995, it was 0.5. If we go over here to 2016, it was 0.6 again. This graph, the top part of the graph is green, and that represents the NDVI values above 0.3, where the bottom part of the graph is brown, representing the NDVI values below 0.3, that threshold that we picked to deem whether an area was productive or not. So you can click on different polygons. If we go click on this red polygon here, you can see that most of the time during that time period, the NDVI values were less than 0.3, deeming it not productive. One of these areas over here, some of the years it was productive, some of the years it wasn't. And the time series graph shows us that. So this information not only allows you to identify areas that are productive, but allows you to see the history, the historical productivity of an area. One thing we can do is we can turn on the satellite background, so we can see what this area actually looks like in real life out in the field, and we can adjust the layer transparency. And this is applicable for all layers on the SGI web application. You can make it so that it's fully transparent, so you can see everything behind the polygons, or you can adjust it, just slide that, and it'll change. So it's semi-transparent, and we can zoom in here and see what's behind these polygons. This is really helpful as it allows the user to locate the area that they're interested in, and to be sure and to kind of confirm that that is truly where they want to look. I'm going to adjust the layer transparency to full maximum here. One thing I failed to mention earlier is we have a short description of the layer underneath the title of the layer. If you click on this button right here, this information button, what will happen is a pop-up window will pop up, and that will give you more detailed information about the layer. It will tell you what it's actually used for, how it was made. It will reference the peer-reviewed publications that were used while making this layer. And so you can gather more information about the layer and how you can use it for your particular planning purposes by looking at this detailed information. Okay, I'm going to turn off the Mesic resources layer. As part of this layer, we have another functionality where you can view very specific years. So if we turn on the year layer, I'll toggle that on now, what we're looking at is a pixel-by-pixel comparison of productivity for the year 2016. And I'm going to zoom out a little bit so we can get the broader landscape here. And so over here on the right-hand side, you can see we have a chart or a grid where you can pick the specific year that you're interested in. Patrick highlighted for this particular region that 1992 was a dry year. And if we select 1992, everything will turn to brown, representing the dryness that he talked about. The legend down here at the bottom highlights that anything that was below that 0.3 threshold of NDVI is that brown color. And as we go above that 0.3 threshold, it gets more and more green. So a dark green probably represents something that's 0.6 or 0.7. A light green is something that's just right above that 0.3 threshold. And so here, looking at 1992, we can see across the landscape that this was indeed a drought year, and many of these areas that were productive in 2016 were not productive in 1992. Patrick also mentioned 1995, that it was a wet year. If we select 1995, you can see the changes that have occurred, the change in productivity. Many of these areas that were delineated through Patrick's automated process were very productive in 1995. And so you can select whichever year you're interested in. You can go to 2010 and look at it, or again, we can go back to 2016. And this is for the entire area. If we zoom out, and you'll see it can work across small landscapes, big landscapes, for all those areas where we already pre-identified the Mesic resources. I'll zoom back in here to this area that we're focusing on. Now, Patrick also showed you a movie where he cycled through the years. And we thought, we got together and we talked about it, and we thought that would also be helpful for our users to be able to see that movie and to see how the landscape changes, both in space and in time. And so if you go over and click on the multi-year tab here, you'll have a grid of years that you can select from. What I'm going to do right now is I'm going to select all years. So I've hit the all year button, and all years are selected. And if you press the play button, it will cycle through the different years and show you that movie of how things have changed from year to year. So right now, it's cycling from 1984 to 2016. And you can see how the landscapes has changed. We went from 1992, where it was a wet year, to 92, where it was a dry year, to 95, where it was a wet year, and we're cycling now through the 2000s. And so you can get an idea of how this is changing in space and time. I'm going to go ahead and stop this movie now. One of the things you can do is, if you're not interested in the whole, that whole continuous range of years, is you can select the specific years that you want. If you hit the None button, it will deselect all years. And for this example, I'm going to select the year 2000, 2005, and 2010. And if you hit the play button, it will cycle through those years that you selected. So you have some control over what years you want to look at. You might just be interested in only wet years. And if you know what those years are, you can select them. We thought this information would be useful so you can get a better idea of how your landscape that you're working in is changing from year to year. The last thing I want to highlight, I'm going to stop the movie now and turn off the specific year layer. The last thing I wanted to highlight is the custom analysis portion of the Mesic resources layer. Now, Patrick did some excellent work where they went through an automated process where automatically all these Mesic resources were delineated and identified automatically. And we were able to identify about 1 million Mesic resources across the western United States. Now, as with all automated processes, they're not perfect. Sometimes we identify, or sometimes we miss things that we should have identified. And knowing that, we wanted to give the user the ability to go in and look at their specific areas that they're interested in and do their own custom analyses. And so when we toggle this custom analysis layer on, you're presented with a blank layer here. What you see is what has changed is over here in the left, we have some controls, some drawing controls. Right now, the polygon drawing control is selected. What that allows us to do is that allows us to draw a polygon over an area that we're particularly interested in. So what I'm going to do is I'm going to zoom in on this creek over here, and I'm going to draw a polygon for this particular area. It's going to be a small polygon, and it's going to cover this wet area right here, right along the banks of this creek. I'm also going to draw a small little polygon over here off to the side so you can see how it looks like it works outside of a Mesic resource. So you can draw your polygons and they're complete. And when you're ready to do your analysis, after you've drawn the polygons that you're interested in, you go over here and you can hit the calculate button. What's happening right now is that information is being sent to our servers in the cloud, and in combination with Google Earth Engine, the information for those specific polygon areas is being calculated. And what we see is this, what is represented in front of you, is similar to the Mesic resources persistence layer, where this shows the percentage of years throughout that time period that this Mesic resource was productive. And this is a custom Mesic resources, one that the user or you have identified within the web application. And you can go, just as you can with the other layers, you can go and click on these polygons or these areas, and a chart will be displayed off to the right, showing the time series of these areas. So you can see this particular area that I clicked on right next to the creek. For nearly this whole time period, it has been productive. It has been above that 0.3 threshold, and you can see how things have changed throughout time. Interestingly, if we go to 1992, which was a dry year for the area, you can see that it had a 0.4 in DBI. So you go to 1995, which was a wet year, it went up to 0.6. But you can gather the same information that you can gather for the pre-delineated polygons, you can gather for your own custom drawn polygons. If we click over here on this red polygon that I drew off to the side of the creek, you see that basically only for 1 year out of that time period was it productive. That is, it was above that 0.3 threshold. And again, that was that wet year of 1995. Just a note to consider when you are drawing these polygons, we do have some limitations on both the size of the polygon that you can draw as well as the number. Any one individual polygon cannot exceed 640 acres. And the total number of polygons that you can draw or submit for analysis is about 50. If you submit more for 50, anything over 50 will just be ignored. So this custom analysis feature of the Mesic resources layer allows you to draw particular polygons of areas that you are interested in. But we also knew that people will already have polygons for projects they have worked on or projects they are planning to do, and they might want to gather information about those particular areas. And so what I'm going to demonstrate for you now is how you can upload a shapefile and run analysis on polygons that you have already pre-delineated or have already created a shapefile for. So if you hit the reset button here, it will reset our custom drawn polygons. And if you hit the upload button, it will open up a box and ask you to upload a zipped shapefile. Now if you go back, and I'm going to hit cancel here for a second. If you go and click on detailed instructions, it will have down here in the 4th paragraph, there are some instructions on how you can do these custom drawn analysis. And it highlights that the zip shapefile must contain 3 parts of the shapefile, and they're listed there. So please make sure to include those. So I'll go back, I'll hit upload, the box will open, and we, for purposes here, we're going to upload a shapefile of a project that was done. There may be a lag as it's processing the shapefile because it has to read the shapefile and process all the points of that polygon out of the shapefile. But once that processing is done, it will zoom to the area of the shapefile. And it may take a little bit longer depending on the size and shape of the shapefile. If it doesn't work, one thing you could do is what I might do here right now is you could refresh the application. So you can go over here. Oh, there it is. For some reason, this took a little bit longer than normal. So you might just have to be patient as it processes your shapefile. But what's sitting in front of you is a particular restoration project that was done. And as you can see, it processed that shapefile, and the polygon is in front of us here, and it's shown. So once that polygon is shown, you can go over here and you hit calculate. And the same thing happens as it does when you have your hand-drawn polygons. It presents the information back to you, and you can go and click on it, and it provides the time series of information of NDVI for this particular polygon. This is the mean, the average NDVI for everything within that polygon. And what you can see here is you can see the restoration for this particular project occurred in 2004, right here. And you can see NDVI was 0.195. As we go throughout the rest of the time series, you can see that due to the restoration, the NDVI picked up, showing the success of this individual project. So what this allows us to do is this allows us to go backward in time as well as forward in time and see how things are responding to the actual conservation or the restoration that we're doing on the ground. This should be a significant tool for you so you can quantify the success of your conservation, your particular conservation project, or your particular restoration project. As with the other layers, or the other layers that I demonstrated, you can adjust the transparency here at the top so you can see below what it looks like. Keep in mind the satellite imagery used here in the background for Google Maps changes from year to year as they update and acquire new imagery. So we're probably looking at a more recent imagery. But given with our time series graph down here at the bottom, we can see what that polygon has looked like throughout time. I'll turn the transparency back on. Okay, so that's a brief overview of the Mesic resources layer. As I said, many of the functionalities I highlighted, the transparency bar, the detailed information, and other things are available for the other layers. As we continue and go forward, as we produce more and more SGI products, science products, they will be available here on the web application, and you can use them for your conservation and planning purposes. So with that, I'll hand it back to Jeremy, and he's going to talk about visualizing and using this information in your own desktop ArcGIS programs, so you can bring these data into your own planning products and use them for your own planning purposes.
Okay, thanks, Brady. This is Jeremy Maestas here, and the last thing I'd like to show you in our video is simply how to bring in some of the SGI web app layers into your ArcGIS desktop planning software. And you can do all that without having to download the layers. And you just simply follow these instructions. On the web app, you'll notice bottom right, there's this icon that says View Data in GIS. If you click on that, it'll take you to a tab with a very simple set of instructions to add these layers as web map tile services. And so I'm going to go ahead and shortcut in the interest of time. I'm just going to copy this hyperlink like it tells me to here, and then I'm going to walk you through these instructions for adding the data. So pull up my ArcGIS. I've already got a project loaded here with several layers, and I'd like to bring in my SGI layers of interest. And so I want to go to Arc Catalog, and that's this icon here. We'll open that up, and under your GIS servers, there's a list of servers. You want to go to Add WMTS Server. If we open that up, you just simply paste that link from the website, and we hit Get Layers. And it went ahead and brought in all of the available layers on the SGI web app. You will not need a username or password to access this. Just hit OK. And then I'm going to close out of my catalog and go up to Add Data. go to Add Data, and you go to your GIS servers. There you go. And so you'll notice here that it's listed twice for me. I had already preloaded these layers. But if you click on you know what you just added, it'll give you a suite of layers that you can select and bring into your GIS platform. I'm going to cancel out of this. Like I said, I've already added those. And so let's go ahead and take a look at the Mesic resources persistence layer, the one that essentially gives you how often these resources are productive in the late summer. So there you go. Very fast. You know, real delays. These would be normally extremely large files, but through this service, we're able to take a look at them. You can't analyze them and do things like that, but for most of our purposes, we just want to make maps. We want to see where they are in relation to our projects. So this will allow you to do that. Couple quick applications that I'll walk you through from a SGI, sage grouse conservation planning standpoint, and just kind of targeting. And so what I normally like to do, and I always bring in our sage grouse priority areas for conservation, right? Those are the landscapes that support most of our birds and where we're focusing a lot of attention on ecosystem restoration. And so I'm going to take you to an example here in my backyard. Let's zoom in and just get a little closer. And first thing I would do is start to take a look at the patterns at a pack scale in your planning area, your work area. You know, so this boundary right here is your pack boundary. That's where most of the birds, the best habitat that's left is. And you can see, you get a pretty good feel for where the Mesic resources are from this mapped layer. Importantly, you also get the colors represent how often that they were productive in that late summer season, at least from an NDVI standpoint that Patrick explained. And so first thing I would do is turn on my Lex. You know, that's always a good reference for, you know, the bird in terms of thinking about breeding habitats and what's going on around those areas. I've created a buffer, 2-mile buffer around those Lex to give me some perspective on scale. You know, how far are these birds that nest in these areas having to go to get to Mesic resources? I'm asking myself lots of questions as I'm thinking about it at this scale. I'm also thinking about breeding densities. One layer that most folks are familiar with is the breeding bird density models. Kevin Doherty has developed. That's recently been updated. And here's what that looks like. This represents basically 75% of the breeding population of birds, the red being the highest density, 25% of all birds. And you can see that's kind of the best habitat. Gives you some idea of perhaps some of the good habitat and areas where you might want to do protection and areas where there may be some restoration opportunities in terms of not only Mesic resources, but a variety of threats that may be going on. All right, another great opportunity we have is to bring in some of these other mapped threats like our tree canopy cover. Because we're in Oregon, I'll throw this up. It's a big deal, and it really constrains where our birds occur. And so as you can see, the white areas here are little to no trees. As you get greener, that's a higher canopy cover of trees. And so most of our birds are kind of pinched in these, at least their breeding habitats are pinched in these areas with few trees. But we could start to think about things like Mesic resources in relation to other threats like juniper as well. Okay, so if you're fortunate enough to have data, we can actually bring in some bird location data. This is telemetry data for late summer season. Gives us an idea of, you know, actual bird use. And so in this particular landscape and the study that was done on this part of the pack, birds like to hang out over here. And so I'm going to go check out and see what's going on with those resources and if there's potentially anything of interest to check out on the ground. All right, let's turn my Lex back on. Okay, so you can kind of see that they've got some good breeding habitat out here, likely open, unfragmented sagebrush, but they've got pretty close access to these little drainages, riparian areas, draws, swells, and most of them, I'm going to turn this back off, most of them happen to be green, which means pretty good. They're pretty functional. More often than not, they're productive. But there are some pieces here that are red, yellow, which means they're, less than half of the time those grocery stores are open, so to speak. And so I'm curious as to what can be done in this part of the world, maybe making the areas that they're already using even better. So I'll drill in a little bit further here just to check this out. And I'm going to go ahead and turn on my aerial image just to see. And if you notice, you can kind of toggle back and forth with the persistence layer. It does a pretty good job of mapping most of the visible green spots on your NAPE imagery. But again, it gives you that temporal aspect too, where you can see how often that green spot is green, which is something we haven't been able to wrap our heads around up to this point. And so, I'm also thinking about, like, as I drill in closer, I can see some trees on the landscape. I'm going to put this back on. We've learned recently that, birds that move into these more productive brood-rearing habitats late in the summer, if those areas have phase 1 or phase 2 juniper in them, it can be an ecological trap. In other words, they want to use it, they need the resources, but they're suffering higher mortality by doing that. And so I'm kind of interested in perhaps what I can do to maybe cut trees around some of these mesic areas to provide a safer access to those resources. So I'm just going to drill in a little bit more. And indeed, it looks like we do have some pretty good tree cover here. Again, if I'm looking at the birds are using it, but is there a cost to them to doing that? And so, I'm just thinking about what more I can do on the uplands. And then when it comes to checking out, these yellow areas, that's something where you're probably just going to want to take a pickup ride with the producer, or take a little hike, and let's walk these draws and see what's going on. I can't quite tell from here. It may be completely natural. They may be just seasonal drainages and supposed to be that way. In some cases, you'll find some incision that's really drained the water table and perhaps led to why those areas are not as reliable as they could be. And so you may have some restoration opportunities there. Let's go ahead and back out from this example. I want to show you a couple others. Let's turn our ortho off and our Mesic resources back on. And I'm going to go to a landscape where, again, down here, southern Oregon, northern Nevada, just want to show you a little bit different landscape where we've got more elevational relief, where the mapped Mesic layer actually captures. This is a big mountaintop, Trout Creek Mountains, and these areas are kind of bottomland sagebrush. Again, we've got some good data on bird use in this landscape from an ongoing study at Oregon State University. So I want to just plug those on and show you, how these birds are really packing into these upper elevation habitats late in the summer. Again, these are July to September bird locations. And so this is really valuable information from a planning standpoint, but I guess I'm sitting here looking at this landscape and wondering about Mesic resources. They don't seem to be a real big limiting factor up here. There's a bunch of them. The birds have this kind of irreplaceable high elevation habitat. If I turn our Mesic layer off and our trees on, this isn't a place that has a lot of trees and other threats. This is pretty well intact. We did have a fire through there recently, but for the most part, this is a functional landscape, and so you might just be in more of a protection mode when you find that you have really abundant Mesic resources. Okay, let's take a look at one other example quick and take you down to Nevada. And I'm going to turn on this population abundance again. This is a spot I was just kind of looking around out of curiosity. Again, this is a big pack in northwest Nevada. We've got this breeding abundance map here, the red being most abundant, orange next, and the yellow being 75% cumulative of all the birds. So it's a pretty good area from a habitat standpoint. The birds are telling me it's not bad. If I turn on my Mesic resources, kind of curious what they have available to them. And in this area, there's not a lot of Mesic resources late in the summer, and so I'm really curious as to where they're going, what they're accessing. But one thing that's caught my attention is, the few resources you do have in the area are reds and yellows. There's a few little green patches, which are probably those grocery stores that they're packing into most years. But some of these areas, there's something going on potentially. So I want to check that out. Let's turn off this population abundance layer and zoom in and see what's going on here. Turn on our aerial image. And it does look like this area is in a bit of a canyon setting, but when I turn off my Mesic resource layer, I do notice that there's quite a bit of valley bottom available, but it's mostly gray instead of green like over here, which is telling me this is probably sagebrush. This is probably an area that's incised at some point in the past and is not quite as resilient as it could be. And the Mesic layer does a pretty good job of picking that up and telling us, hey, the red area, it hasn't been very productive over the last 30 years in the late summer, whereas these areas have been able to maintain a high water table and grow those green groceries. So I'm going to drill in just a little bit further, take a close-up look at this area. And indeed, it does look like we've got a channel that's probably downcut, created a bit of its own inset floodplain again, but nowhere near the potential that it once was in terms of its productivity. When you get into this setting, this is maybe a great candidate for active restoration, especially given its location within grouse habitat. Of course, you can do this stuff anywhere in the range, but we're using grouse to help us focus ecosystem restoration and try to have more impact for more species and for producers. So I'm going to show you one last thing here, and that is just, once you're at a project scale, in addition to the persistence layer that tells you over time how things are changing and it averages conditions over that area, you can actually look at within years. So this is just 2016, what NDVI or that vegetation index looked like. And the little boxes or the pixels are 30 meter by 30 meter Landsat pixels. So it gives you a finer grain look at the productivity within this valley. And again, that green mostly follows that small incised channel. And so this would be something that, over time, as we continually update the web app with the new annual layers, you can start to measure and quantify post restoration success and changes through time. And some of the more custom analyses that are possible, you'll want to go back to the web app and run to get those charts and whatnot through time. So with that, I just want to go ahead and wrap up and say thank you for joining us in this video series and for your interest in Mesic conservation. I encourage you to check out our Sage Grouse Initiative website and contact us anytime if you have questions. Thank you.